Cool. So I have a game that I recently played, pulled up here on chess.com. And over here I have my chess algorithm, my chess model running. And what we're going to do is we're going to analyze the game that I played. I didn't win, so this is a losing game. I'm going to analyze the game and try to see if my model would have caught my mistakes and then found the better moves. So, interestingly, we will be able to use the chess.com computer to see the goodness or badness of moves. But I also was able to go through this game with a friend who's a fairly strong chess player to get the human interpretation of the moves as well. So I'll try to provide both angles. So the way it works is I'm going to play a move, copy the representation of the board into my algorithm, and then it's going to output two numbers. This number represents the badness of the move, and this number represents the goodness of the move. And then if the good number is higher than the bad number, it will print out good move. And if the bad number is bigger than the good number, it will print out bad move. And so the way that I would use the algorithm to play is I would try a particular move. So perhaps in this case, pawn to e4. I would run my algorithm. If it prints good move, I'll play that move. If it prints bad move, then I'll run the algorithm on a different move until I find a good move. So we're going to run this game, but before we get there, let me just show you how the code works. So it takes in an input of the board as a representation in this format called FEN, and then it converts this string here into ones and zeros using this line. Here's the code that turns into ones and zeros. And then these four lines it's a little bit of a sloppy program, but what it's doing is once it converts the chessboard into ones and zeros, it saves those ones and zeros to a temporary CSV file. And then I call this function compute move, which is up here, which then reads that CSV file and determines if the move is good or bad. So I probably don't need to go to the CSV, but it's the fastest way I figured out how to implement this whole thing. And so it reads the CSV file, and then it makes a prediction based on the model, which is up here. And if this is the bad number. If the bad prediction is higher than the good prediction, it prints bad move as we saw. Or if the bad move is less than or equal to the good prediction, it prints good move. Oops. All right, so that's how the code works. And then up here is the model. So you'll see we have 4 hidden layers, each of width 60. Basically what that means, and then also actually before I get to that, up here you see that the input to the model is 768 ones and zeros, and it outputs two what are called classes. In our case, those classes are bad and good. So in total, this entire model requires, I think, 59 or 56,000 parameters. So it's a little bit high in terms of what I'm hoping to memorize, but the performance of this model is almost perfect. So now I guess the next step would be to try to optimize it to see if I can reduce the amount of memorization required. But anyway, this model works pretty well and is in the human range. If I really wanted to, I could learn this and play solid chess. So let's actually see how it does. So the first 10 or so moves of this game are all fairly standard and all good moves. So we have another good move. And we're just going to go through this pretty quickly. It's a good move. Castling. Good move. This is standard stuff. Good move. All right, almost at the interesting bit. Good move. Bishop there. It's a good move. Knight, another good move. All right, almost to the less good moves. Okay, so this first move, according to the computer, is not. I mean, I lose 0.2 centipawns, which is something, but it's not. It's not the worst thing ever. It's definitely not an inaccuracy. It's a very playable move. When I reviewed the game with my friend, he mentioned that he would never play this move, but it is playable. Let's see what the algorithm thinks. So the algorithm says it's a good move, so it is fine, but there probably are better moves. But trusting the algorithm, I'm going to push ahead and play this move. Pawn takes. It's a good move. Okay. So here I make the first mistake. Let's see what happens with the evaluation. So again, it's not the biggest swing. And so the computer thinks it's, at least this computer thinks it's probably passable. My friend mentioned that this is not the best move because I'm not anticipating where this knight goes. On the next move, the knight wants to come here. And so it would be better if I could play a move to prepare or to defend this square, either pawn up like that. So it's a good move. Or maybe the bishop comes back. Also a good move. But instead, in the actual game, I play this rook move. And let's see. So the model does say this is a bad move. So in the actual game, I would have computed on this move, realized it wasn't very good, and then maybe tried some other move until I found either this pawn move or this bishop move. All right, but anyway, let's push ahead. Knight comes down as I was not prepared to defend. I didn't defend, so the knight comes. All right, so if you watch the evaluation up here at this top part, this queen move is a mistake or an inaccuracy according to the computer. So this is the first pretty significant mistake. I've almost lost a full pawn in value here. And the model catches this as a bad move. So if I had used the model during the game, during this game, I would have seen this queen move as bad. And so I would have tried some other moves. And let's see. According to chess.com, a better move was c3. So let's try c3. And that's a good move. So I might have found that in the actual game, in which case the evaluation goes back to being equal. So fair, even chances for white and black. But instead, I play this queen move. The queen comes down. And the queen's threatening, I guess, checkmate, or at least a pretty dangerous check. I guess the king has a place to go, but this is getting a little hairy. The next move I play is pawn comes up. That seems like a fine move, and the model says it's good. The knight takes, and now I actually make a very big mistake. I lose a piece. I should have taken with f takes e3, so I should have taken with this pawn, and let's see. That would have been a good move. The evaluation's still not great, but in this position, it's probably the best move. Instead, I overlook this somehow, and I decide to take with the queen, which was, as you can see up here, a big mistake. And the model catches that too. So if I keep playing the game in this way, first of all, would have never gotten to this position. I would have made, I guess, a move like this, and would have had a bit of a lead. And so the model's working great, which is really awesome. The next step would be to optimize it, see if I can make the actual memorization portion a little bit smaller. But the actual math, right, is just straight matrix multiplication, which is just a lot of additions and a couple multiplications. So, yeah, it's looking good.